Alrighty, everyone. So today we're just going to learn about molarity and what it means and how to calculate for it, including the equation that we use in molarity. So first of all, what molarity literally is simply a unit of measurement for concentration. And it's going to be denoted by this capital M that you see here. So when you see big M, you know that that stands for molarity. That is not to be confused with little m, which stands for mass. Okay. Some other sections or in the reference sheet, you'll see molarity denoted by C. That just means concentration. And they'll specify if they're speaking about molarity. Now, the actual definition of it is the moles of your solute per liter of solution. So from there, we know that we're just going to take the amount of moles of solute that we start with and simply divide it by the amount of liters of your total solution. So we have a couple of units for molarity, the first one being that big M we were talking about. This is one of the most common ways that we'll see it denoted. Another way is to literally take the two unit of measurements that are being used here. So you could also write molarity as moles per liter. These two both mean the same thing. The combination of moles divided by liters will give you big M. Another way to write it is simply by bringing this liters at the bottom all the way to the top. So it would be moles times inverse liter. All of these mean the same exact thing. They are just the unit for molarity. Now onto the actual equation for molarity, or the formula for it. It's just going to be M is equal to N over V, where this big M is the molarity. The little n is the moles specifically of your solute or whatever you're measuring. And this big V is going to be your volume. And remember, this has to be in liters. So let's actually run through a problem. So we have 0.2250 moles of sodium chloride is dissolved in 0.500 liters of water. So right now, let's write down what we've been given. We've been given moles. Remember that moles is denoted by this little m, 0.250 moles. And we have our volume in liters, which is 0.500 liters. And then what they're asking for is the concentration of the solution. Right now, we only know one unit of measurement for concentration, and that's molarity. So what we're looking for is big M. Lucky for us, we have a formula to solve for big M. Remember, that's molarity is equal to N over V. And remember that N is the moles of your solute. In this case, our solute is sodium chloride. And V has to be specifically your volume in liters. Now, if we look at what's been given to us, we have our moles of solute, that's sodium chloride, and we have our volume in liters. So we can just plug and chug all of these values. So up top, you could put 0.250 moles, and at the bottom, you'd have 0.500 liters. And from here, you would just calculate that using your calculator. So it would be 0.25 divided by 0.5. And you'll get 0.5 as your final answer. So it'll be 0.5. And remember that both of our numbers that are given to us are in 3 sig figs, so it should be 0.500. And we'll express it as molar. You could have also written it down like this. You could have written down as 0.500 moles per liter. This is still an acceptable answer. However, we'll typically write it with this big M. All right, so let's move on to another one. 36.7 grams of calcium fluoride are dissolved in 250 milliliters of water. So already there's a big difference compared to the last one. In the very last one, we were given our moles of solute. This time, we're given the mass of our solute. So let's either way write down what we're given. We're given mass of our solute, which is 36.7 grams, and it's specifically of calcium fluoride. Calcium fluoride is CaF2. And we're given our volume of the solution in milliliters, 250 ml. And they're asking for the same thing. What is the molarity of the resulting solution? So we're looking for big M. Now remember, the equation for molarity is N over V, where N is the number of moles and V is the volume in liters. If we look and see what we have so far, you'll notice that none of our numbers or none of our units match what is needed. However, we can determine both of these numbers from this. So first off, let's start with our volume. The volume should be expressed in liters. It's currently in milliliters. That's an easy conversion though. You just take this number, 250, and you divide it by 1,000. So you should end up with 0.250 liters. That's the easy conversion. Now the more complex one would be converting this amount of grams of calcium fluoride into moles of calcium fluoride. Now to go from grams to moles of a specific substance, you would have to use that substance's molar mass. If you don't know how to determine that, you would just use the periodic table. So for calcium fluoride, you have 1 calcium and you have 2 fluorides. So you're going to take the mass of 1 calcium, that's this number right here, and you're going to take the mass of your 2 fluorides. So it should be 40.08, this is calcium, plus 2 times 19, that's the 2 fluoride ions. So our molar mass is 78.08 grams per mole. Now I have all the materials that I need in order to convert this mass into moles. So I just take 36.7 grams of calcium fluoride and I divide that by the molar mass. So it'll be 1 mole up top, calcium fluoride, and then it'll be 78.08 grams of calcium fluoride. Here, grams cancels out, and you're left with moles. So it'll be 36.7 divided by 78.08. And so you should get 0.470 as the amount of moles. And now the very last thing to do, we now have both of the values that we need. We have moles of our solute, that's the N, and we have the volume of our solution in liters. So now we just need to plug in these values. So it'll be 0.470 moles over 0.250 liters. So this will be, divide this number by 0.25, and you'll have a molarity of 1.88. Cool. So step by step again, you're given the mass of your solute and you're given the volume of your solution in milliliters. In order to find the molarity of your substance or your solution, you need to take the moles of your solute and divide it by the liters of the solution. So the first thing that we did was we converted milliliters into liters. You just divide by 1,000 for that. And then we took the mass of our solute and used its specific molar mass to determine how many moles of it exist. Then we just plugged both of our numbers in. Let's do one more. So, how many grams of solute exist in a 0.375 molar solution of nitric acid? Okay, so we can take some things out of here. We're asking for the grams, aka the mass. We have the molarity of the solution, and we have the identity of our solute, which is nitric acid. And then lastly, the total volume of the solution is 750 milliliters. Okay, so we have a solution of nitric acid, which is HNO3. And we know that its molarity is 0.375. So this time we're given the molarity of our solution, and we're given the volume in milliliters. And what's being asked of us to find is the mass, or the grams. So we're looking for little m. Okay, so right now I only have one equation to work with molarity. All I know is that molarity is equal to moles of the solute over volume of the solution. At the moment, I have the molarity, that's 0.375 molar. I can get the volume of the solution by just dividing this number by 1,000, so this would be 0.750 liters. So now, at this moment, I have these two values, and I don't have the amount of moles. But we're not looking for little n, we're looking for this little m. So we don't want moles of our substance, we want the mass of our substance. The great thing is, we can actually convert from moles into grams of a substance by using that molar mass. So let's actually prep that up before anything else. So in this case, our formula is HNO3. So you're going to take the mass of one hydrogen, you're going to take the mass of one nitrogen, and then the mass of three oxygens. And that will be the molar mass of nitric acid. So let's calculate that. It will be 1.008 plus 14.01 plus 3 times 16. Those are those three oxygens. And so you should end up with a molar mass of 63.02. All right, and the units for it are grams per mole. Okay, so let's actually rearrange this equation to actually solve for n. So first, we're going to multiply both sides by v. That means that v gets canceled out on the right side, and now n is by itself. So we have n is equal to big M times v. Okay, so now we can plug in our big M and our v to solve for moles. So n is equal to 0.375 molar times 0.750 liters. When you do that, it's going to be 0.375 times 0.75. So you should end up with 0.2813 moles. Specifically of nitric acid. Now we're not done yet. Remember, we were asked to find mass, and so far we've only found moles. We can use this amount of moles and our molar mass to determine the actual mass of nitric acid. So I'm going to take this number, 0.2813 moles of HNO3, that's nitric acid, and then simply multiply it by the molar mass. So it'll be 63.02 grams of nitric acid per 1 mole of nitric acid. Here, moles cancels out, and you just have to perform this operation. So you're going to multiply this number by 63.02. And you should end up with a mass of 17.7 grams. Oh, my mistake. So in the beginning, you were given actually two different numbers. This 750 ml is just 2 sig figs. So in reality, you would round this down. You would round this up to 18 grams of HNO3. And this would be the final answer.